Okay, just to try something different, I want to film the dog in her comfy armchair and show off how nice her new haircut is and the fact that we can see her eyes. Although it's been 5 days since the haircut and it's already getting harder to see her eyes and her fur is already looking curly. It's crazy how fast it grows. But she's very cute and especially cute to me when she's newly shorn like that. Okay, I'm a little shaky here with holding the camera, but I should be able to get this set up and start my lesson. Now, that's not too bad. The angle seems a little wrong. How's this? Okay, sorry for having to get so close. It looks okay. Let me see. How far do I reach? That's fine. That's fine. Okay. So, as you can see, this week's lesson is percent, and it is going to be a review. And yes, there's a dog there, and I'll show her to the camera at the end again, like the usual way. But I just wanted to see if I could do this. See, what's annoying is that you can flip the camera, but when you're partway through recording the video, it doesn't give you the option to flip the camera. So that stops me from being able to film her nicely and then put it there and film myself. I don't know why I'm complaining. What a waste of the first minute and a half of a lesson, eh? Okay, so the dog's all right. It's still cold out. I still don't want to talk about it, but I can tell spring is going to come sometime soon. I think maybe in around 3 weeks, I'm going to start noticing that massive melting, and it's going to put me in a good mood because there's a lot of woodworking stuff and other type of outdoorsy stuff I want to do. Yes, I know this looks weird, that I need for the snow that's all over the backyard to melt. I don't mind if there's a few snowbanks left, but I need it to just melt down to grass so that I can clean everything out of my shed. I really can't wait to get going with that because the shed's getting messier and messier. And it's hard to clean it unless you take a bunch of things out. And I don't want to take things outside and put them in snowbanks. Okay, so now I've wasted the first 2.5 minutes of the percent review. And all I will say else is, this is the Hurricanes. That is a rugby team from the southern island of New Zealand, and one of my favorite teams and one of my favorite jerseys. And now let's get into percent review. Now this is where things get interesting because I am going to use student suggestions for every single question that I work on in this week's review. That's a little tricky. I didn't even prepare any, so we have to come up with something for everything. But the good side of it is because it's a review and there's so many different topics, we don't need 20 examples of something. We don't need more than 2 or 3 examples of each thing. So first I'm going to ask for a suggestion from a student, and I will keep on looking at the comments. Yes, that's how we do this. I'm looking for a suggestion from a student for a number that we can express as a fraction, a decimal, and a percent. Of course, percent is the focus right now, right? But just to review the concept that we started with, which is that a percent is just a number, and any number can be expressed as a decimal, a fraction, or a percent. So I'm waiting for some ideas to come up in the chat. And I won't be too fussy about what I'll take. Where's my chalk? So if a student gives me correctly a fraction, a decimal, and a percent that all go together, I'll use it. But if the student gives me a fraction and then their decimal doesn't match that fraction, I might still use it. Let me decide. I have to decide. Yes, now we're at 4 minutes. 4 minutes, and he hasn't done any math yet. Okay. Okay, I'm going to take 0.38 as my example. I kind of like that. Yeah, 0.38. So that obviously is a decimal. Okay, now which direction should I go at first? Percent or fraction from this decimal? So this is decimal, of course. I'll do it like that, and then we'll convert this into both of the others. So I like to go to the percent. When you have a decimal that goes to the nearest hundredth, it converts into a percent so cleanly that is going to be 38%. I guess I could put the word percent in brackets here, but it's kind of obvious, isn't it? But I'll do it anyway. So there's the percent version of this decimal number. And then the fraction now, I can go directly from a decimal to a fraction, but I really like going from a percent to a fraction because it reiterates, as I said, reviews, it restates. How many synonyms can I come up with for saying this? Okay, it restates my very first point that I made when I first taught you percent, which is percent means out of 100 in French. So therefore, 38% means 38 out of 100, and it allows us to so quickly turn that into a fraction. And yes, I will write the word fraction in brackets. And yes, I also will admit that yes, this is a really easy question for all of us now, which is why I only want to do one example like this, and we can move on to the next thing. Okay, so any number, if you get the number given to you in a fraction or in a decimal or in a percent, you can convert it into each of the others. And it's usually very straightforward. This is a very straightforward one, but even the more complicated ones become easy with practice. And so practice is necessary. It's math. Okay, what is, that type of question. I want to do two examples of this one. Pardon me, I'm just keeping an eye on this device and that other device all at once. Fortunately, I only have 3 devices. 2 of them are laptops, and then there's you. Okay, I have to turn the volume off on that one. So I'll try and gracefully zoom over there and do that while I don't interrupt this lesson at all. Okay, I need to erase. What we're going to do is that type of question. I'll use a brand new clean eraser cloth. The type of question when you say, what is such and such a percent of such and such of another number? And those ones are actually hard to the percent students at first, and then we spend pretty much a whole lesson on them, and the students get very good at it. So what is, not really a word problem, not too many words involved, what is something percent, I haven't chosen, well we haven't chosen because I want to see students' suggestions. What is something percent of, and then we have some other number. So I see some suggestions popping up. What is 22% of 17.5? You know, I think that's okay. What is 22% of 17.5? If it were the lesson where we were just starting to teach this, I'd think, okay, that one's a little bit complicated, but it's a review, so it's not too complicated. 22% of 17.5, and there's different ways of doing this. I remember showing more than one way when we were doing a whole lesson on these, but the way I like to do it is to know that 22% converts into 0.22 in decimal form. I tend to do a lot of my percent calculations by quickly converting the percent into a decimal. And then of in mathematics often means multiply, and it does mean that in this case. And then, of course, we're multiplying it by 17.5. And then this looked like it was going to be complicated, but then it doesn't look very complicated. Now, of course, we could multiply these with pencil and paper. We know how we did that when we were doing our decimal multiplication lessons, but we're also allowed to use the calculator. Where is it? So I will use the calculator. 0.22 times 17.5 equals 3.85. Oh. Turns out 3.85 is 22% of 17.5. That's cool. Not something that you would just guess correctly, and pretty difficult one to do in your head. But we can verify it because I want the students to feel comfortable with this, that yes, it works. We're not just trusting a calculator to do our thinking for us. We're able to think our way through this. If we had to do it without a calculator, we could. But let's verify over here by saying that means that 3.85 over 17.5 should be equal to 22 over 100. I'll put a squiggly line there. And then we could do cross multiplication to see if the verification works. So therefore 17.5 times 22 must be equal to 3.85 times 100, Remember, bottom times top equals top times bottom. That's what we did here. This is an easy one to do without a calculator. 3.85 times 100 is 385. But 17.5 times 22, I'll use the calculator. 17.5 times 22 equals, yep, 385. And yes, that multiplication I also could have done pencil and paper because I know how to multiply decimals. That's fun. Let's do another one. I'm going to take another student suggestion. So if you haven't already typed one up there, do one. I'm going to remove just the 17.5 and the 22 from the question here. And we'll do the same thing, but I'll try to show the steps differently, just to make it interesting. Okay, students putting decimals inside percentages. What is 11.5% of 180? Well, that's not so bad. The student at least didn't put decimals in both and start doing really crazy stuff like giving me repeating decimals or something. I'm not afraid. I'd still be able to answer the question, but I don't want my examples to be too complicated. So 11.5% of 180. Last time I converted that to a decimal, and then I just multiplied it by 180, and we know that will work. The last example, I just converted this into a decimal and multiplied it by the other number. And we know that will work. But another way of doing it is what we did in the verification. 11.5% means 11.5 out of 100. We know that. And then the tricky part of trying to solve it this way is simply, would I make a mistake and put the 180 in the wrong position here? But 11.5%, I know I've done the right number on the top, the right number on the bottom. That's a bit easy. Of 180, of tells me that the 180 needs to go on the bottom. Slow down and think about it. And so therefore, if I solve this cross multiplication, I should get the number that is 11.5% of 180. Let's predict. 11.5%. That's not too different from 10%. We know 10% is a tenth of. So we're looking for a number that's a tenth the size of 180. So 180 is a lot bigger than 100. So if they asked what is 11.5% of 100, well, the answer would be 11.5. But they're asking what's 11.5% of a number that's almost twice as big as 100. So we should get an answer that's almost twice as big as 11.5. Let's see if that happens. Cross multiplying 100x equals 11.5 times 180. Using the calculator, 11.5 times 180, 2070. But now we have to divide both sides by 100. So we can cancel over here. 2070 divided by 100 is going to be 20.7. Dividing by 100 is one of the easy ones with decimals. We move the decimal place, which would be right here. We jump it 2 places to the left, and it gives us 20.70 or 20.7. So 20.7, and that is almost double 11.5. So I feel very confident in that answer. Going it the other way, 11.5% would be 0.115 in decimal form. Move the decimal 2 places to the left, right? Yes, it would. Times 180. We're really doing the same thing, aren't we? 0.115 times 180 equals, yep, 20.7. Being able to do the question different ways is powerful because it makes you stop and think about why it works. Why does it work to do it this way, but also work to do it that way? That sort of thinking makes us step back a little bit from the problem and think about why the math that we're learning works instead of just remembering steps. Remembering steps is useful, but knowing why the steps work makes the steps more useful, and it makes you remember. It makes you remember how to do it for longer, maybe forever. So that's why I really want to try to get the students in my class to do that. So that's it for the examples for the what is blank percent of what type of question. I'm already have used 15 minutes of my hour, but I do admit that I wasted the first 4 minutes talking about a dog and stuff like that. So let's get busy and move on to the next type of question. The dog's busy. She's grooming herself. You just went to the groomer last Thursday. Why would you need to groom yourself now? She's a dainty little thing, combing the fur on her paw with her teeth. Okay, she does think she's a cat. Next type of question. When you have a percent discount and you calculate, well, what is the discount? How much money am I saving? But then there's the other type of question that goes right along with that, which is how much will I pay? So I like to answer both. So let's say I'm going to ask a student to suggest a discount, and I don't want a percent with a crazy decimal inside it or anything like that. So try to choose something that sounds like percents that you actually see when you see advertisements for sale prices and such. And you can also suggest the price of the item, because I need to know the percent of the discount, but I also need to know the price of the item, or else I can't calculate it. And I don't mind if I take those two numbers from two different students either. I don't want 25% because you just hear that too often. 15%. You know why I'm choosing 15%? Because that's the discount I got when I was an employee at a store once, many years ago. So it just rang a bell. And then which item should we buy? Okay, I'm looking at the types of items. Some people are buying little teeny things that are inexpensive, and some people are buying ginormous things like houses. And I want something that's more in between. No one's saying what the item is. I'm just sort of $455. Okay, not too complicated, but also it's possible that we would get a repeating decimal or something like that. So it's not necessarily a super easy one either. Lie down. Lie down. Thank you. Stay. Okay, so this is the discount. This is the item price. Let's say it's a television or something like that. I want to know what my discount is. How much am I saving? But I also want to know how much I pay. I actually want to know both of those things. It might be easy to just say, look, just calculate how much I have to pay. That's all I need to know. But when you're deciding whether you got a good deal, whether you're happy with the good deal or not, it helps to remember what that other number was. Okay, so what is 15% of 455? That sounds like a review. That's 15% times 455, which is 0.15 times 455. That's one way of doing this. And I think it's the logical way of doing it. So I convert my percentage to a decimal and I multiply the decimal by the item price. This is not going to give me the amount that I pay. This is going to give me the amount of the discount. And it's good to remember that because, well, we'll see what would happen if we mistakenly decided that this was giving me the amount I pay. Okay, 0.15 times 455. I'll use the calculator. 0.15 times 455. 68.25, not a crazy decimal. Now, if we were to mistakenly think, oh, I'm going to get a TV for $68.25, that's a good deal. Well, yes, it would be a good deal, but that's not what's happening here. That is the discount. So if we want to know how much the TV will cost, we have to subtract that from 455. We have another step. $455 minus that gives me $386.75. Thank you for the good question. It did not give us a crazy decimal. I didn't even have to do any rounding. It gave us the sort of decimals that work really well with money. But sometimes that's kind of just luck. Thank you, and I did take these two numbers from two different students, so thank you both. Okay. Is there a way of getting this amount right away instead of having to calculate the discount and then subtract? There is, and I want to talk about that because it is a review. So I am allowed to say, okay, but let's think about what's the best way of doing it. We can do stuff like that. So one way is to say, well, where should I put this? I think I'll just start over here. 100% minus 15%. Is this going to go off? No, it's still fitting in the rectangle. Equals 85%. So therefore, this should be 85% of 455, and I know it is. but I'm thinking that way. When I first did the problem, if I really didn't want to know what the discount was and I really just cared how much I had to pay, this helps me to get that. So I can't really say it's less steps because this, let's face it, this is a step. But if I were to take, let's make sure I have room, the 85% and say, what is 85% of 455? In math, I would write that as 85% times 455. Need more chalk. But that means 0.85 times 455. And when we multiply these two numbers, we expect to get this as our answer. So let's do that. 0.85 times 455 equals 386.75. Yes, $386.75. So two different ways of doing the same thing. This way we found out what the discount was, which is useful knowledge. And then we found out how much we have to pay, both useful knowledge. This way we modified our percentage so that instead of finding the discount, it would find the amount we have to pay directly. And if I really wanted to know what the discount would be and I hadn't done all of this before, I would have to do another step. I would have to say 455 minus 386.75. And yes, of course, I'm going to get 68.25 as the answer. So which is faster, which is more efficient? This one actually only took 2 steps, and I got 2 very important pieces of information. This one took 3 steps, 1, 2, 3. And I got the same 2 very important pieces of information. So I guess it is more efficient to just do this. I don't know. It's worth it to think your way at a problem from 2 different directions and then compare them and think about it. It's part of that learning process. Okay, did I want to do 2 examples of that? Do I have time? You know what I'm going to do is I'm going to make a mark. I need a pencil. I'm going to circle that. And if we have time at the end and I want to fill more time to fill up the lesson to an hour, I'll go back and I'll do another example of that. In the meantime, I think I want to move on to another question, which isn't very different. When you think about it, a lot of the ones that are money, a lot of the business math stuff ends up being very similar to each other. That the math parts are extremely similar. And we're using these tools in our toolbox, all of this percent knowledge, little percent tricks we've learned, but we're using decimal a lot, aren't we? We use fraction here and there. We use decimal a lot when we're working with percent. So, erasing all of this, I forgot to bring out a can of fizzy water. And I think I should get one. So I'm going to do the thing I really don't like doing, which is to walk off camera. And I know she's going to get all excited and think we're going upstairs for supper, and she's wrong, we're not. I'm going to go over to the fridge, which I could have showed you before when I was holding the camera in my hand, because it's just over there. But what I want to do is put something on here first. So, I need student suggestions for a sales tax question, because that's what I'm doing next. And it's similar in the sense that we want to know 2 things. We want to know what is the tax that we're paying, and we also know what is our final bill that we will pay. So, I'm asking for a student to suggest a sales tax, maybe from where you live or some number that's a reasonable sounding sales tax that they might charge somewhere in the world. Sales tax amounts vary depending on where you live, and also the price of an item. Let's see, let's make sure the item is less expensive than a TV, but more expensive than, say, a candy bar. So I'm looking at first I'm seeing suggestions for taxes, and what I'm going to choose is 9%. That's a good, reasonable sales tax. It might be the sales tax somewhere. It's not the sales tax where I live. And more than a candy bar, less than a TV. Oh, that's a complicated one. $127.95. not too many TVs that cost that little, but I suppose then you might find a small TV. This just screams power tool at me because, as you know, I love power tools and I buy them quite often. And I always have to kind of talk myself into it if it's an expensive one, but this one's not that expensive, so it wouldn't take too long for me to talk myself into it. Okay, so the problem is, and I'm not answering the problem yet, I want to get fizzy water, remember? So the students can work on this because you have the information you need. If you have a 9% sales tax and the item costs $127.95, how much is the tax going to be, but how much is your total bill going to be? I'll be right back. Stay. And yes, just to clarify, when I said stay, I wasn't talking to you. I knew you would all stay. I was talking to her. And I didn't even have time to choose a flavor. I just grabbed one as soon as I saw one that I knew for sure would be fizzy water. This one is the calamansi citrus and strawberry flavor. And I need to dry the chalk dust out of my mouth right now. Okay. Okay, so 9% sales tax on $127.95. Not very different. It's not a discount though. So that's one thing that's different. Sometimes you have a sales tax to calculate and a discount to calculate at the same time, and we will move on to problems that are like that. But this time, let's just worry about the sales tax. Let's just deal with the sales tax. I'm not worrying about this. 9% is 0.09 in decimal form times 127.95. I will not show the dollar sign here. I'm converting into math language. Percent into decimal, now I'm multiplying. And yes, I could do it showing all the steps on pencil and paper, but I'm going to use my calculator. And it is going to be 0.09 times 127.95 equals 11.5155. So we have to do some rounding. Which means $11.52. Because the number after the 1 was a 5, so it rounds up to $11.52. To know how much I have to pay, I have to add those. So I can show that here. And I won't use the calculator because, well, multiplying decimals without a calculator might take a bit of time, but adding them is not so bad. 2 plus 5 is 7, 5 plus 9 is 14, that's a 4, carry a 1, 7 plus 1 is 8, plus the 1 I carried, that's 8. I need a decimal here. I always put the decimal later than I should. Okay, and then 1 plus 2 is 3, and 1 plus nothing is 1. Oh, we have $138.47. That makes sense. And then the other way of doing it, of course, is to say, well, 100% of this is $127.95 plus the 9% tax I have to pay. That gives me the decimal 1.09 times 127.95, similar to what we did in the last example. But I wasn't subtracting a percentage from 100%. I was adding a percentage to 100%. 100 over here, 100% plus 9% equals 109%, which of course converts into this decimal. And of course I know what the answer is going to be. We all know, right? The students got the answer a long time ago while I was still fetching water. 1.09 times 127.95 equals 139. Uh-oh. Oh, I made a mistake. What did I do? Did I punch the numbers incorrectly? 109%. 9%. I have to do this over again and double check it. 0.09. I did not expect this. Times 127.95 equals 1151. 1152, yes, with rounding, plus 127.95 equals 139. Oh, so this was wrong. Now I see the mistake I made. I made the mistake when I was adding the decimals. I didn't even have to do it. I could have used the calculator. He never learns his lesson. Okay, 7 plus 1 is 8 plus the one I carried. I even remember saying that part. I said it correctly out loud and then I wrote it down wrong. 7 plus 1 is 8 plus the one I carried is 9. Thank you. Oh, I feel better now though, because it makes sense now. So yes, 1.09 times 127.95 equals. How come none of the students typed in that I had done this wrong? I didn't see a single. It's too late to look at the chat, but because it scrolled up. But I didn't see anyone saying, "Hey, you made a mistake." Did any of you say that? You can type it now. Say, "I told you and you weren't listening." You can type that now if you want. 139.46, but the number after the 6 is a 5, so I have to round. And it's going to be $139.47. Same answer. I like doing this and using 1.09. I don't know why I like it so much. I just like it. I like it better when I can do that. It's fun. I don't know. I guess it makes it fun. Okay. Again, I'm taking a long time for everything. Everything's taking longer than I thought. So I'm circling that as another type of question we can do a second example of later if we have time, because I want to move on to the next type of question. How many of them do I have? Too much yakety yak from this guy, and too many mistakes. The mistakes slow you down too. Okay, we're going to increase the cost of something, and I will ask a student to give me a percent increase, and the same, or another student to give me the cost of something. So it can be anything. It can be something expensive or something small, and I'll just choose something that looks like it'll be fun to do. So the students have enough time while I'm erasing to come up with some ideas. Yes. $3.55. We already used that number anyway. $3.55 is going to be the price something was, but it is increasing by 1%. And what percent should we use? No, I don't want a nice round number like 20. It's too easy. 16%. I'll take 16%. Okay, what costs $3.55? I don't know. It's like some big fruits, like melons. Some big fruit. And there's a 16% increase because it's not in season anymore or something like that. It's not in season locally, but it's still in season in some other place where there are shipping costs to send it to us, and it's not going to be as delicious or as perfectly ripe as it is when we buy it locally. Yes, buying produce locally is good. Okay, 16% increase on a price that was $3.55. So very similar question. Kind of like the tax. We could rephrase this question if we wanted to say, what if there was a 16% sales tax? That would be a lot on a thing that costs $3.55. So mathematically, it's really the same operation, and we just changed the situation. But a 16% price increase, it should not be increasing prices by such large amounts. I find it scandalous. Okay, 16% is 0.16 in decimal form, and we're going to multiply that by 3.55. And this is going to be a quick one. Not really that different an example. When I was making up these different topics, I was thinking that these were all different from each other. They don't seem to change that much from one to the next. 0.16 times 3.55. 0.568. But we have to round because the price increase, this is a price, this is an amount of money. So we want money rounded to the nearest hundredth, so therefore it's 0.57, and that's money. I can put a messy little dollar sign that looks horrible, or I can write more neatly, and there. So a 57-cent increase has to be added to the $3.55. Uh-oh, he's adding decimals again. Can you do it without making a mistake? Put the decimal right away. At least I didn't make that mistake. 7 plus 5 is 12. I put the 2 and I carry the 1. 5 plus 5 is 10. Plus the 1 I carried is 11. He's being really careful. But I have to carry another 1. 3 plus 0 is 3, plus the 1 I carried is 4. So this item now costs $4.12. It was only $3.55 yesterday, and now it's already $4.12. Why? Because there was a 16% price increase. Silly. Okay, so I'm making up questions and answers. I like this one. Now, this one feels a little different. So my next type of question I want you to give me a price, but then there's one of those specials where they have reduced the price, but they're not telling you the percent. They're just telling you what the new price is. So I want an original price and a new price that's lower. And let's say more than $15 and less than $100. Looking at the chat. $82.50. That's the price. That's the wait. I didn't even ask, is that the original price or the new? Okay, so I'm going to just say that's the original price. I'm doing one of these ticket things. There's the price tag. There, it's got a little circle hole in it so that you can attach it with a string to something, that type of price tag. But we're crossing this out because they have knocked that price down to something much more affordable. So I'm going to choose something that I think is much more affordable. No, $21 is not, I don't believe the price would go down that much. So I'm going to do $68.55. Okay. And that's a good one, because it's not too simple. And it's believable. Okay, so if I was about to buy something that costs $82.50 and I got there and I saw this price attached to it, I'd be thinking, oh good, it's not $82.50 anymore, it's $68.55, but what percent did I save? So it's just the same sort of type of math question, but asked kind of backwards. What percent? So we're back to doing something that sounds like our very first examples near the beginning of the lesson. $68.55 out of $82.50 is equal to what percent? Oh, this is a way of solving it, or an equivalent way. So across multiplying 82.50, I'll write 82.5. X is equal to 68.55 times 100. Easy one to do in head. Move decimal, jump decimal 2 places to the right. 6,855. But now I'm going to find something that I don't want to do in my head. I'm going to use the calculator. Chalk whistling? Okay, cancel. 68.55 divided by 82.5. It sounded like the chalk was whistling. I have some special type of chalk that whistles. Okay, 68.55, 6855, no decimal in there anymore. Divided by 82.5. 83, oh. I didn't calculate the discount. I accidentally calculated the percent of the old price that I'm paying, which is not what I wanted. The answer's not wrong. I just didn't calculate what I wanted. But I'm going to just fix that by doing it right next. Okay, so 83.090909, so that is 83.1%. So if you pay $68.55 when it was supposed to cost $82.50, you are paying 83.1% of what it originally cost. Which isn't really how most people would talk about it, is it? They'd say how much they're saving. Of course, the convenient thing is that it's a percentage. So we can subtract it from 100. 100 minus 83.1 equals 16.9. It turns out that this was a 16.9% discount. It makes me start to think maybe I know the reason why they wanted to show it this way instead of telling you what percent you're getting off, because 16.9% is a weird percentage to have as special, but it's also not, it doesn't seem like a lot. It's a little bit more than 15%. So, I like a discount. I like a 15% discount. It's better than no discount. But maybe 15% or 17% doesn't sound that special. But then when you see it this way, it's interesting. I wonder what it is that the people who run the store are thinking when they decide to do it this way. And maybe that's what they're thinking. Maybe they're thinking 17% doesn't sound that great. Maybe it won't attract the customers. But when they see a price like that and they see this noticeably lower price, maybe that's going to get people more excited. I don't know. I'm just guessing here. What am I doing? How am I doing for time? This lesson, the time is flying past. I was expecting to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At least 22 examples. And with what I'm seeing right now, it's going to be quite a lot fewer. What's my next one? When you have both a tax and a % discount coupon. I like that type of question. So it's a good news, bad news type of question. I'm going to let students choose the % of the tax, something that's reasonable. That sounds like a real tax that might happen somewhere. And the % off coupon, that % amount. And then I will also entertain suggestions for what the item price would be, but I might just insert that myself. Okay. So you know what it is that I want suggested. Okay, I need a tax, I need a % off coupon amount, and I need an item cost. I'll take the 8% tax. I think 8% is a pretty common sales tax. So let's say 8% sales tax. And then the coupon, 40% off. Wow, that's a good coupon. And the amount. What is the item? What is it we're buying, and how much does it cost? $500 even. $500. There, we have all the information we need. The thing is that we have to do two things at once, and one of them, and like I say, good news, bad news. One of them is sales tax, which increases how much we have to pay. That's the bad news. And another one is the 40% off coupon, which decreases the amount we have to pay. And then we have that little question that a lot of people ask, and it's even people who've been buying things all their lives sometimes will stop and say, wait, I'm not sure what will happen now. Do we decrease the price because of the coupon first and then calculate the tax? Or do we calculate the tax first and then decrease with the coupon? And I know which is the way it's usually done, and I agree with the way it's usually done. What we should usually do is, I think we should always do, as far as I know, is we apply the coupon first, and we calculate the tax later. Because when you think about it, if you want customers to have an argument for how you're doing things, people would say, wait, are you telling me that you're going to charge me tax on $500 price, even though I'm buying an item that costs way less than that because I have this coupon? That would sound bad. So we're going to do the $500 minus 40% first, and then we're going to apply the 8% sales tax. So how do we do this? $500 minus, I'm showing this stuff slightly differently. So I'm doing a minus, because remember, this is a discount. So it's a minus, not a plus. 500 minus, and then I show 0.4, which is the decimal version of 40%, times $500. I like doing it this way. So what will happen is this will calculate the discount, but then that will be subtracted from the 500, and we'll find out how much we actually have to pay. and that's useful. So this becomes 500 minus, now can we do 0.4 times 500 in our heads? 0.4, 40% of 100 would be 40, but there's 500, that's 5 times as big, so it's 200. It's going to be 200. But of course, yes, we're allowed to use the calculator, and yes, the teacher has learned his lesson. 0.4 times 500, 200. Ah, so we have 300. So 44% off is great when you're buying an item that costs $500 because you get $200 off. You only have to pay $300 for that $500 item. That's great. Of course, that is the good news, and then there's the bad news. We also have to apply the sales tax. So we have $300, but we are adding 8% to $300. I'm doing it this way again. 8% is 0.08. Remember, careful of where you put the decimal when you convert. This is a 1-digit percent. So it's not going to be 0.8. That would be an 80% tax. We do not want to pay 80% tax. 8% tax is 0.08 in decimal form. Is this going to fit? Yes. Times the 300. Took me a long time to get around to showing that part. So this is going to be the 300 we have to pay after our discount coupon. But then we have to add the tax, and this is going to calculate the tax. So we have 300 plus 0.08 times 300 is going to be 24, right? 0.08 times 300. Yes, 24. Therefore, we are paying $324. Even though I have to pay tax, an 8% sales tax, I'm feeling pretty good about my purchase because it was supposed to be $500 this thing. And with that great coupon, I ended up paying $324, even with the tax included. That's okay. Good savings. Thank you, student, for suggesting. I wish these students could come along when the next time I'm going to the stores and buying things, because some students have some pretty good ideas. Okay, tax and percent off coupon, that example is done, and I did only intend to do one example of that. There's only 13 minutes left in this lesson. Tax and tip. Okay, I'm just going to do it. I'm going to do it fast. I will grab numbers from there, but I'm not going to talk about it too much because I have 5 more things I want to fit into 13 minutes. So we're going to do tax and tip. Type in anything you want into the chat because you know what it is that I'm looking for, and if I find one that I like, I'll do it. Okay, so tip. What's the price that we're paying? I see a $42 restaurant tab, and the tax, or I don't want to use 8% again. Let's use 7%. 7% tax is being applied. The restaurant, yeah, it depends on where you are, whether they, what they tax and what they don't, and I'm not going to worry about that. So yeah, there's a tax of 7% on this amount. I don't even care if it's a restaurant tab anymore. It's $42 that we have to pay. There's a 7% tax, and we want to tip the standard 15%. We won't argue over whether that's too much or too little. 15% is very common, at least. Whether you think it's too much or too little, it is very common. Okay, so we have to do both of these things. How do you do this? We do the tip on the subtotal, but we calculate the tax on the original amount. So what we need to do is 2 steps, and we have to be careful. 7% of $42, that is 0.07 in decimal form times the 42. Calculator, can't waste time now, can't waste time. 0.07 times 42 equals $2.94. That is the tax. Then we do not add that to the $42 and then calculate our tip on the total. We calculate our tip on the subtotal. So we want to do 15%, which is 0.15 in decimal form, times the 42. So in a way, this type of question, you have 2 separate questions to answer. And then you combine the 2 answers to answer the overall situation. 0.15 times 42. 6.3, which means $6.30. So our bill is going to be the $42 plus the tax, which is $2.94, plus the tip, which is $6.30, calculated on the subtotal, not on the total, plus the $6.30 tip, $6.30. Total amount we're going to pay for 2 carry the 1, 6, 8, 10, that's 11, put the decimal, carry the 1, 51.24. No mistakes this time. 42, 48, 50. Yes, $51.24 is the total we end up paying if the value of what we bought was $42 and a 7% tax was applied and a 15% tip. So yes, it makes sense if this happens in a restaurant, but there are other places where we tip. Okay, so that one was quite fast. Good. There's time. There's still time. Percent change. I need a starting amount. How does this one work again? What's my formula? I need to actually look at the formula because I don't want to get it mixed up with percent error. Where's my percent change? I am looking at the notes on the laptop. Where is percent change? There it is. Where's the little formula go there? That's what I want. Okay. Yes, new minus old over old times 100. Yes, that's percent change. So it doesn't have to be money. It can be anything. So tell me a new and tell me an old. Situation to apply. I see numbers and I was thinking of age, and I don't want to do that question. Something costs 25 cents. And now it costs $1.85? I guess you could say that about anything that costs $1.85 these days. And at some time in the past, that thing would have cost 25 cents. So we could come up with a situation if we want. But the students are giving me numbers and that's enough. What is the percent change? So we have to know what's new and what's old. It is possible that something that's $1.85 would cost only 25 cents now, but that's not usually what happens. So I think we can say this is the new, that's the old. We now apply it in our formula. The percent change formula, which I'm not scrolled to show anymore, is new minus old over old. I will write it like this. New minus old over old times 100, because that's what makes it turn into a percent, is going to be 185 minus 25 cents, which is 0.25, over 0.25 times 100. I'm doing it as fast as I can because I want to get to the other examples. 185 minus 25 is 160. 1 equals 160 over 0.25 times 100. 160 divided by 0.25. 1.6 divided by 0.25. 6.4 times 100. Oops. Times 100 equals 640. That is a 640% increase. Remember, with percent change, you need to say whether it's an increase or a decrease. Okay, that's a good example. Next one is percent error. Scrolling down to show that formula, which is not very different. But that's where we have estimated minus actual. So someone suggests an estimated, suggest an actual. And in this case, we don't really have to say increase or decrease. We just want to know how far off we are. But you can still point out if it's an increase or a decrease if we really want to. This is fun. I just find it's fun when students suggest the questions, and even if I do make mistakes, it sort of puts me on the spot to prove that I really know how to do this, and I haven't just memorized some questions with answers that I found on the internet or something like that. Yeah, you admit it, you were suspicious I might not actually know how to do all this math. 5 minutes left. I am not going to have time to finish everything. Whew. Maybe I should just slow down and stretch this example over 5 minutes. No, okay. Percent error. That's where we need. It's estimated minus actual. Estimated minus actual over actual times 100. Suggest an estimated, suggest an actual. Estimated for 48.4 minus actual, same student, where to go? 20.1 over actual, that we need the 20.1 again. And remember, the most common mistake here is accidentally putting the estimated on the bottom. No, it has to be the actual. That appears twice in the formula. Times 100, don't forget that. 48.4 minus 20.1, I can do that in my head. That's going to be 28.3. Yes, 28.3 over 20.1 times 100. And I'll use the calculator for this part. 28.3 divided by 20.1 equals 1.407 times. I'm going to do the times. No, I'm going to write 1.40796. I'm just writing a bunch of the digits times 100. Now I'll multiply by 100 right away, and I get 140.796. So that's 140.8% error. More than 100% error, but yes, 48.4 is more than 2 times as big as 20.1. So when we stop and think about it, it makes sense. Hardly any time left. I wanted to do simple and compound interest problem, and I will. What I'll do is I'll just allow the lesson to get a little bit longer than the planned hour. But I'm going to try to keep this simple, okay, simple and compound. So we have simple interest and compound interest. And I'll write the formulas for them. I equals PRT. For this one, I equals P. No, P is a capital P, lowercase r, lowercase t. And then the compound one. Of course I have these memorized, but I just don't want to make a mistake. A equals P, 1 plus r to the t, yes. A equals P, 1 plus r to the t. Let's just have an amount that's being invested, a percent interest, and a number of years, and we'll just do years, but I don't mind if it's like 36 and a half years or something like that. So the amount is going to be $15,000. The interest is 6.2%, and the number of years is I don't want 3.7. How about 37? I'll just take that number and say it. No, I'm rejecting 3.7 years, and I'm putting 37 years. Okay, so in the piggy bank, or the coffee can, or the many other hiding places that we could think of to keep our money safe without actually earning any interest, in 37 years, that would be $15,000. I won't even calculate that. I'll just say it would stay $15,000 no matter how long you kept it hidden, so long as you didn't lose it. I equals PRT is 15,000 times 6.2%, but I have to convert that into 0.062. Be careful of where your decimal lands. Times 37. Calculator. There's less than a minute left in the official lesson time. Times 0.062 times 37 equals $34,410. That was a long investment. $34,410. But I have to add that to my principal. So it'll be $49,410. Pretty good investment with simple interest, much better than the piggy bank coffee can approach. It 15, 20, more than tripled. But 37 years will do that. Now this one, principal is still 15,000. 1 plus R is 1 plus 6.2%. I want to show the steps. To the power of the time, which is 37, that's a 3, equals 15,000. Need more chalk. 1 plus 6.2% is 1 plus 0.062, so it's 1.062. I'm sure if I made a mistake, that's where I would make it. To the power of 37. And then we have to bring 1.062 to the power of 37 using that key in the calculator we now know about. 9.2599, I'll call that 9.26. Which we can now multiply by the 15,000. Ooh. $138,898.76. Much better return on the investment than the simple interest. And both of them so much better than the coffee can method. The under the mattress method. And why did it happen? That's all we'll talk about. We're over time. Why did it happen? Because we started with a fairly large amount. And boy, that's a long time. So yeah, that really helps to make the return on the investment seem huge when you invest for a long time. And the interest rate not too bad. Okay, so that is this week's lesson. Thank you very much. It was fun. Thank you for all the good suggestions. And we're going to be moving on to something different next week, because when you do a review one week, usually you're starting something new the next week. I look forward to it. This dog wants to say goodbye. Oh, almost as much as she wants to go upstairs and eat supper. She's fur is very soft right after being groomed. And she even still smells good, because I haven't let her roll in anything when she goes outside, because she still smells like that lovely shampoo. Okay, thank you very much for everything. I will see you next week. I am looking forward to it.